Welcome, mathematicians. Today we're going to learn how to factor. Thank you for taking the time to visit my channel. I'm going to show you some essential techniques that you need to know if you're taking any algebra class or you're going to take any algebra class. So the first thing is we have to build your arsenal, your skill set, which is key, okay? You have to know how to factor. You have to have all those weapons right there ready and available to you. So there are certain skills, okay, which you have to know for college classes and for just any algebra class. And those are finding the GCF, the AC method, the rational root theorem, U-substitutions, completing the square, and the quadratic equation. You need to know all of these. The first one, the GCF, that stands for the greatest common factor. And that means just most simply finding what things have in common. Okay, that's the question you have to ask, is what do all these terms have in common? So let's look at the first one. Just by looking at that, what do these terms have in common? Well, we can tell by the numbers alone that they must share a 4. Okay, and now looking at the letters, looks like they share an x and a y. So that's our like term, is 4xy. Now what we're going to do is we're going to take that out of the problem and we're going to put everything that's left over inside parentheses, okay? So on the outside we're going to have 4xy, whereas on the inside we're going to have the leftovers. Now notice if we distribute it back in, we get back to our original problem. So that is really, this ability to take the GCF is so important. Alright, now let's get on to the good stuff. Factoring method 1, the AC method. So let me explain what that means exactly. First, let's look at the form of polynomials. Most of the time they're going to be in this form, ax squared plus bx plus c. So the first thing that we want to do is multiply a and c, hence the name AC method. So multiply a and c, and then find the factors of AC that add up to b. Alright, so let's take our example, 6x squared plus 7x plus 2. So step 1, multiply a and c, so 6 times 2, which is 12. Okay, now take the factors of 12. So here they are, we have 1 and 12, 2 and 6, and 3 and 4. So step 2, find the factors that add up to 7. So which of these do you see that adds up to 7? Well, you can see here that 3 plus 4 adds up to 7, giving us our factors. Now we're going to rewrite the problem with 3 and 4 in place of 7x. So it's going to be 6x squared plus 3x plus 4x plus 2. Notice how if you add 3x and 4x together, you get back to 7x. So now what we're going to do is we're going to group these terms together. So we're going to put the first two in parentheses and then the last two in parentheses. And then this is where we have to use the GCF. So what is the greatest common factor of the first parentheses and what is the greatest common factor of the second parentheses? Well, if you do it, you're going to get this, 3x and then what's left over and then 2 and what's left over. And you should notice that what's left over will always be the same. And if it's not, you might want to back up and take a look and see if you did it correctly. So now at this point, we're going to take the greatest common factor again. So what do you see that they have in common? Now don't look small, okay? Don't look at the numbers, but think large, okay? They have the 2x plus 1 in common. That whole expression, they have that. So we're going to take that out, leaving us with 3x plus 2, that was what was on the outside, is now coming together as the leftovers, and then what we took out, which was 2x plus 1. Alright, method 2. Just as important, it's the rational root theorem. Now this usually comes up when you're dealing with larger degree polynomials like this. So step 1, we're going to take all the factors of the last term. So our term is 6, so the factors of 6 would be 3, 2, and 1, as well as 6. And then we're going to take all the factors of the first term. So in this case, it's just 1. But if there was a number there, you would take all the factors of it, just like we did for the last term, sorry. Okay, so then the possible roots are the factors of the last term over the first coefficient. Okay, so that means that, if we have 6 and 3 and 2 and 1, then all of those are possible roots. But remember, for this, they're all going to be plus or minus. So it could be a positive 6 or a negative 6. And what you're going to do is just go through trial and error, test each one, and see which one produces a 0 in the original function. And you can see that's going to be kind of tedious because you have 8 different numbers to try. But for the sake of time, I know that it's -1. So if we plug in -1 into the original function, you see that we get a 0. So from there, what we're going to do, knowing that -1 is a root, we're going to use synthetic division. Now, I don't have time to explain what synthetic division is, but make sure that you look it up. So basically, in short, just take all the coefficients, do the operations, and you're going to get your new polynomial. So all of those are the coefficients of the new polynomial. I mean, excluding 0. So let's construct that polynomial right now. So it's x squared plus 5x plus 6. By the way, if you get a 0 at the end of your synthetic division, that tells you you did it right because that's a remainder of 0. So you're fine. Perfect. Awesome. All right, now at this point, I mean, that's basically just the AC method. So if we factor that, we get x plus 3 and x plus 2. Excellent job. All right, factoring method number 3, U-Substitutions. All right, usually when you see things like this, x to the 4th minus 13x squared plus 36. Notice, though, how the first degree, the highest degree, is twice as much as the next degree. And when it's in that type of pattern, that's usually a good indication that it's the U-Substitution type of method. So what we're going to do is we're going to let U, and hence why we call it U-Substitution, we're going to let U equal x squared, and U squared is going to be, have a typo there. That's supposed to be x to the 4th. I'll put that in the video though. And then what we're going to do is rewrite it in terms of U. So we have U squared minus 13U plus 36. And now at this point, that's pretty easy to solve using the AC method. What are the factors of 36 that add up to -13? Well, we get 9 and 4. So we have U minus 9, U minus 4. And what we're going to do now, remember, set it equal to 0. So what you're going to get officially is U equals 9 and U equals 4. But remember, don't stop here, okay? These aren't technically your factors because U equals x squared. So you have to say that x squared equals 9 and x squared equals 4. And then what you're going to do is take the square root of both sides, giving you plus or minus 3 and plus or minus 2. Remember, taking the square root always gives you the plus or minus option every time. All right, number 4. Completing the square. All right, so let's give our example here. Notice though, you could do this with the AC method. That's perfectly fine, and if you can, you're doing great so far. This is just for the sake of knowing how to do completing the square, okay? So step 1, set this equal to 0, okay? And then what you're going to do is if you see a number in front of x squared, just divide by that number. Now sometimes there isn't any number there, so just imagine that you divide by 1. So we're going to divide by 2 in this case, and we get these funny fractions here, and then what we're going to do is we're going to take the 3 halves and move it over. Awesome. All right, now what we're going to do is we're going to add in this term, the b times 1/2 squared term, to both sides of the equation. Okay, so you're thinking, well, what's b? Just remember, the function is f of x equals ax squared plus bx plus c. So our b is that 7/2 term. Okay, so 7/2 times 1/2 is 7/4 raised up to the second power is 49/16, and that's the term that we're adding to both sides of the equation. All right, now if we simplify this, we get x plus 7/4 squared equals 25/16. Now you're wondering, how in the world could I even factor some funny fraction like that? Well, here's the trick to it. You see how it's x plus 7/4? Well, the 7/4, that comes from the b times 1/2. So when you see b times 1/2, just remember that that's actually what it's going to end up factoring into. Okay, so that'll save you the major headache of trying to factor 49/16. You know, where do you even begin? So just remember, it's always b times 1/2. That's what goes in there. All right, and then from here, just take the square root of both sides. So you get plus or minus 5 over 4. Remember the plus or minus. And then subtract 7 over 4. And your two factors are negative 1/2 and negative 3. All right, factoring method 5, the quadratic equation. This is sometimes the most preferential because when all else fails, you can just go straight to your hard-earned, I don't know what I'm trying to say, just your memory. You can just pull that out and just, use that. So you got to look at this, memorize this. My teacher used to sing a song when I was in high school. She used to say x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Yeah, all right, I don't know. Whatever helps you, whatever you can think of, go for it, all right? Now, remember that f of x equals ax squared plus bx plus c. So you can see that the a, b, and c are going to go into the quadratic equation in their proper spots. So here's our problem, x squared plus 3x plus 2. Now notice if there's no number written in front of x squared, we automatically assume it to be a 1. Awesome. All right, so let's plug these in. So that's negative 3 plus or minus the square root of 3 squared minus 4, 1, 2 over 2 times 1. Okay, now what we're going to do is simplify that. So we get 3 plus or minus the square root of 1 over 2. And then let's break that apart. So that's negative 3 minus 1 and then negative 3 plus 1. And if we simplify that even more, we get negative 2 and negative 1. Awesome. So congratulations, people. You made it. Now, you want to review this, okay? You seriously want to go over all of these techniques. And if you know how to do them, wow, let me just tell you, you are going to be so happy that you took the time to learn it because it's going to help you a lot. Gold star for you guys. Awesome job. Hey, don't forget, if you like the tutorial, please subscribe, leave a comment, thumbs up, and check out some of my other videos. I'll have more coming soon.